there are several truths that emanate from a right triangle. Some of them have been categorized under what is called trigonometric identities. We are going to be considering a few of them in this video. First, let's consider a right triangle. We know that a right triangle is one that has one of its angles to be 90 degrees. So if this right triangle is A, B, and C with the right angle at B, of course, the value of the right angle is 90 degrees. And we know that since this side, BC, is opposite to angle A, I can just label it lowercase a, this lowercase c, and this one is lowercase b. Now, from one of our videos, we know that the sine is the ratio of the opposite to the hypotenuse. The cosine is the ratio of the adjacent to the hypotenuse. And the tangent is the ratio of the opposite to the adjacent. If you want to see the video, just click on the link at the top right hand corner of the screen. Now we can apply these three ratios to this right triangle. Let's do that, starting with the sine. So if this angle here, if it's just represented by theta, so the sine of theta is going to be the ratio of the opposite to the hypotenuse. So this is the opposite, the side AB, which is lowercase c. The hypotenuse is the longest side, that's the side AC, which is lowercase b. Similarly, the cos of theta is going to be the ratio of the adjacent to the hypotenuse. So this is the opposite, this is the hypotenuse. So the line BC is the adjacent. So we've got lowercase a over the hypotenuse, that's lowercase b. And finally, tan of theta is equal to the ratio of the opposites, that's lowercase c, over the adjacent, that's lowercase a. Now, before venturing into the identities, we can actually figure out that for any angle theta, its tan is the ratio of the sine to the cos. This is a very interesting argument to make, because if we consider the right hand side, we know sine theta to be c over b and cos theta to be a over b. So I'm just going to write divided by a over b. From elementary math, we know that this division sign can just change to a multiplication, and I'm going to flip this fraction. So it's going to be b over a. B can make way for b, and I see that my right hand side is c over a, which is exactly what tan theta is. Therefore, we can see that the tan of any angle theta is the ratio of the sine to the cos. So let's show some trigonometric identities. The first one we are going to show is that sine squared theta plus cos squared theta is equal to 1. Okay, already we know what sine theta is, so I'm just going to focus on the left hand side. So and just work my way through and see if I get a value that's equal to the right hand side. So I know what sine theta is. So if sine theta is c over b, so sine squared theta is going to be equal to c over b squared, and this is just c squared over b squared. Also, if cos theta is a over b, then cos squared theta would be a over b all squared. Of course, from indices, the square is going to affect the numerator and denominator, so that's a squared over b squared. So let's see if I add these two items, if I'm going to get 1. So sine squared theta plus cos squared theta becomes c squared over b squared plus cos squared theta is a squared over b squared. If I take the LCM, of course, I've got the same denominators here, so the LCM is just going to be b squared. So I've got b squared. Since the denominators are the same, I'm just going to add the items at the top. So I've got c squared plus a squared. So this is sine squared theta plus cos squared theta. We can see that the numerator looks somewhat familiar. Yeah, that's the Pythagorean theorem. So if we return to this right triangle and apply the Pythagorean theorem, and we know that the Pythagorean theorem states that the square of the hypotenuse is equal to the sum of the squares of the opposites and the adjacent sides. So in this triangle, lowercase b is the hypotenuse, so b squared equals, the opposite is lowercase c, so that's c squared. The adjacent is lowercase a, that's a squared. And we can see here at the top that we've got c squared plus a squared, which has the value of b squared. Therefore, I can conclude that sine squared theta plus cos squared theta, which we found to be c squared plus a squared over b squared, is equal to b squared over b squared, and this is equal to 1, because, of course, going by this, I can see that this is b squared over b squared. Therefore, we can conclude that sine squared theta plus cos squared theta is always going to give 1. The next identity is going to be a follow-up to this one. What we are going to do now is we would divide both sides by sine squared theta and see what happens. So we know that sine squared theta plus cos squared theta is equal to 1. So let's see what happens if we divide both sides by sine squared theta. So we would have sine squared theta plus cos squared theta over sine squared theta, and also the right side would be 1 over sine squared theta. So this is a long one, so we can actually split the sine squared theta across the both of them. So this is going to be sine squared theta over sine squared theta plus cos squared theta over sine squared theta is equal to 1 over sine squared theta. Now, sine squared theta divided by sine squared theta can just make way. So I've got 1 plus, now cos squared theta over sine squared theta is cot squared theta. So this is cot squared theta. And of course, 1 over sine squared theta is cosec squared theta. How did I come about all of this? From our previous video, we found that cot theta is equal to 1 over tan theta. And since tan theta is sine theta over cos theta, therefore 1 over tan theta can be written as 1 divided by tan theta, which is sine theta over. Now dividing this, I need to change this division to a multiplication and flip the fraction on the right. So this is 1 times cos theta over sine theta. And we know what cos theta over sine theta is. That's cot theta. So if cos theta over sine theta is cot theta, definitely cos squared theta over sine squared theta would be cot squared theta. And similarly, we found in the previous video that 1 over sine theta is cosec theta. So if we square both sides, we're going to see that 1 over sine theta all squared, which is the same as 1 over sine squared theta, would also be cosec squared theta. So this is the second identity, this one right here. 1 plus cot squared theta is equal to cosec squared theta. The next thing we are going to consider would be the third identity. This is the second one. So the third one, we are also going to start off from the first identity, sine squared theta plus cos squared theta equals 1. But unlike what we did here, when we divided both sides by sine squared theta, now we are going to divide both sides by cos squared theta and see what happens. So also, I can split this cos square across the two items at the top. So this is going to be sine squared theta over cos squared theta plus cos squared theta over cos squared theta is equal to 1 over cos squared theta. And we know what sine squared theta over cos squared theta is. That's tan squared theta. It's tan squared theta because sine theta over cos theta is tan theta. So each one of them having squares would just be tan squared theta. And of course, cos squared theta can make way for cos squared theta here. So I have 1 equal to, now 1 over cos theta is sec theta. Therefore, 1 over cos squared theta would be sec squared theta. That's the short form of secant. And this is our third identity. Tan squared theta plus 1 equals sec squared theta. If you find this video useful, kindly like, share, drop a comment, and do not forget to subscribe. Thank you for watching. See you in the next video.